I'm going to now focus on the blue clay formation. I asked myself the question, well, how much detail am I going to give you with regard to the composition of the blue clays? And I decided that I'm going to probably give you more detail than you really care to know. And the reason for this is because it provides an example of the sorts of things an archaeologist needs to know in order to establish the provenience of the artifacts he's studying in the archaeological record. In my case, it involves my studies of the ceramic artifacts of the Neolithic Temple period and Bronze Age of Malta. Specifically, one of the questions I want to answer is whether or not the ceramics represent locally made objects or objects that were imported into the island. For me to answer that question, I have to know something about the chemical composition of the clays that make the ceramics. Specifically, I want to look at the ceramics trace elemental composition. The trace elemental composition of the ceramics should be the same as the geological clays that were used to make those ceramics. And the trace elemental composition of the geological clays is specific to each geographical location. Therefore, the trace elemental composition of the clays found on Malta would have a different composition than the clays, say, found in Sicily or in Africa or somewhere else. In order for me to have a good understanding of the trace elemental composition, I need to know something about how the blue clays were formed and what they're composed of. In the case of Malta, the blue clay formation was deposited during the Middle Miocene in a deep and open marine environment. This tells me some of the sorts of minerals and compounds I expect to find within the blue clays. Specifically, Malta's clays are made of foraminifera, which are plankton at small single-celled plankton animals that have a perforated chalky shell. They're made of calcium carbonate. They're made of also feldspar, biotite, and zircon. Feldspar, biotite, and zircon are only found in traceable amounts, and they are essentially minerals that are made from degraded volcanic ash. Because they're made from volcanic ash, this would indicate that they originated from somewhere else, because the Maltese Islands are not volcanic. There are no volcanoes on Malta Gozo. More than likely, these minerals were laid down in the blue clays from an eruption from a volcano, say like Mount Etna in Sicily during the Middle Miocene. In addition to these minerals, there is gypsum, iron oxide, glauconate, and magnesium. Gypsum, iron oxide, glauconate, and magnesium generally increase as you move closer to the green sand layer, which sits above the blue clay formation. Additionally, the clays are mainly composed of kaolinite, which is a layered silicate mineral. With regard to the calcium carbonate content of the clays, they vary throughout the blue clay formation, but generally increase as you move toward the Globigerinoid limestone formation, which is the lower layer beneath the clays. And this is important to note because the amount of calcium carbonate affects the trace element of strontium. Strontium levels increase as the calcium carbonate content increases. However, rubidium, another trace element, decreases as the amount of strontium increases. Therefore, strontium and rubidium, in this particular case, have an inverse relationship. The top of the blue clays have about a 6 to 10% calcium carbonate composition, whereas the bottom has a 67% calcium carbonate composition. If you look at this picture, you may be able to see alternating pale and dark gray bands. So, for example, you see a darker band generally here and a lighter band generally here within this particular outcrop of clay. The paler gray bands have a higher proportion of calcium carbonate. And this makes sense because as we go towards the bottom of this outcrop, we get closer to the Globigerinoid limestone formation, and that would influence the amount of calcium carbonate found in this particular area of the outcrop. This is important to know because when we analyze the ceramic wares, we can not only determine whether or not the clays were made locally, but also from where within the outcrop the ancient potter extracted the raw materials to make his ceramic. So real quickly, I'll just review the key concept. Essentially, what I'm doing is comparing the trace elemental composition for the clays that make up the ceramics found in the archaeological record for the Neolithic, Temple period, and Bronze Age of Malta, with that of the trace elemental composition of the geological clays found in Malta. And I'm also comparing them with clay samples found in Sicily. If the clays that we used to make the ceramics that I analyzed are local, those ceramics should have a trace elemental composition similar to those found in the blue clay formation.